Pre-calculus, it's time for the bell curve, chapter 9.5. Let's start it, we're on page 468. Let's go ahead and get started on the bell curve. So if you guys notice on page 468, when we deal with a bell curve, it's because it looks like a bell, right? So this looks like a bell where our x bar, our mean, is dead center in the middle, right? So there's our x bar, which would have a z-score of 0 because we're 0 deviations away from the mean at the mean. But if I were to go over one standard deviation, that is my x bar plus a standard deviation to the right in the positive realm, that would be a z-score of 1. Whereas if I went to the negative realm, if I went backwards one standard deviation, that's a z-score of a negative 1, right? And so if I keep going out there that way, I can go ahead and calculate the percentage of values that are within my standard deviation or my z-score. So, you know, we learned that there was one standard deviation in either direction is 68% of the data. And if you go out one more standard deviation, you're getting 95% of the data. If you go out one more standard deviation, that's 99.7% of the data. So the question that we're going to have here is, what if I am using a z-score of 1, and we had a table where we can start looking this data up because it's not always going to be even like 1, right? And so what would that be if I wanted a z-score of 1? What if I only wanted to find the positive standard deviation? I didn't want to go backwards one standard deviation. I just wanted to go forward one standard deviation, right? So if I did that, or I just went forward one standard deviation over here, my z-score would be 1. You go to the table on page 469, that table, you go down to the 1, and I don't want like 1.1 or 1.2, I want exactly 1, so it's 1.00. So you look at your table at 1, you find 0.00, and that's going to give you 0.3413. Go look at it at the table, you got to find it. That's going to tell you that 34.13% of the data lies in a standard deviation or a z-score in the positive direction. Just this green part. We're not going backwards a standard deviation. But what if they ask it in a different way, like example number 1 on page 470, which says, what if it is from 0 to 1.63? Like, I don't know what 0.63 is, right? So that's why I need my table. So you look at your table on page 469, and you find 1.63. Remember, I'm not going backwards still. I'm still going forward. And look at page 469 table. 1, go down 1, find 0.63. And you end up with 0.4484. That's the data telling you the percent is from 0 to go 1.63 standard deviations, or a z-score of 1.63. If you go out that way, 44% of the data would be in that realm. Now, if you had to go back the other direction too, you'd have to double that. But in this case, we don't. But in that case, we do. Example number 2 actually has both. We have to go, what is 0.6 standard deviations from the mean? Both directions. We got to go positive 0.6 standard deviations and negative 0.6 standard deviations. That is to go 0.6 of a z-score both directions. So I look up 0.6 in my z-score chart on page 469, and when I do that, I get 0.2257. But that's just from 0, from the mean, to 0.6. I have to go back the other direction too, so I got to double that. I got to take 0.6 here, find it. It's the 0.2257 in my my chart. And I have to double it, 2 of those, because I go forward and backwards. When I do that, I get 0.4514. That's 45% of the data would fit between 0.6 and negative 0.6 of my mean. Okay, let's go ahead and move on to example 3. Page 470, example 3. So what if the z-score happens to be greater than 0.98? All this stuff from 0.98, almost 1, all the way on till infinity, what percentage of the data is there? So what we're going to do is, if we looked at the graph of this, we're saying at 0.98, right before 1 standard deviation, but I don't want this section of stuff. I want from here all the way out that way. How do I find that? Well, half the data is between 0, the mean. I mean, this is half the bell curve. Half the bell curve's over there, right? So if I went to 0.98 on my table, page 469, went to my table, found out that 0.98 gives me 33.3365, right? It's 33%. If 0.9 gives me that, that's the stuff to the left. That's this piece, right? But I don't want that, because I wanted the stuff after 0.98. So if half the data is going to be over here, right? Half the data is over there. I need to subtract off the part I don't want. I only want the stuff after 0.98. So if 0.98 on the table gives me 0.3365, then 0.3365 is here. I want to subtract that from 50%. So if I take 50%, 0.5, and I subtract off 0.3365, I'm taking the whole thing, subtracting off this missing piece I don't want, which leaves me with the stuff over there. That's 16% of the data, or 0.16, 16% of the data. So that tells me that after 0.98, there's 16% of the data. Let's go ahead and move on to example number 4. Example number 4 says, well, what percentile rank of a student that scores a 29% or 29 on a quiz when the average is a 27? You see, so they scored better than average, but the standard deviation is out 4, right? Every standard deviation is out 4. So I drew the little graph here. It's on page 471. You guys could follow along. If 27 is the average, that's the x-bar, the mean, and the standard deviation is 4, that means from 27 to 31, that's 1 standard deviation. But I don't want to go all the way up to 31 because they said the kids scored 29. So I only want to go to 29. Well, what is a z-score of a 29? How far up, how many standard deviations is 29 if 31 is 1 standard deviation? It's not a full standard deviation. So the way I figure that out is I go over here and I say, to find a z-score, you take the kid's score, you subtract off the average, the x-bar, and you divide by the standard deviation. That's going to give you 2 over 4, or 0.5. That tells me we're only going to go up a half a standard deviation, right? If a full standard deviation is 4, then that would make sense that half a standard deviation would give you the 29. That would only be up 2, right? So half a standard deviation gives you a z-score of 0.5. And if you go to your table on page 469, 0.5 has a z-score here value of 0.1915. That tells you the value, what percent is going to be in there. That percent is this sliver right here. That's the sliver from 0 to 0.5, right? Just right there. That's the 0.1915. But this kid did better than everybody who scored, less than the 29. So he did better than these people, but he also did better than half the curve over here. So if you take the first half of the curve, and then you add on his little sliver there, then the first half of the curve plus his little sliver is a total of 69% that he did better than. That value would mean 69% of the people did worse than him. He's at a class percentile rank of 69.15. Let's do our last example. It's example 4 time. So go ahead, look here. It's example 5 time. Example 5, page 471. Can we go backwards? What if they were to tell us that we have our bell curve here, and I wanted to go up 22% that way and back 22% that way? If I went 22%, then where would I be on my table? What would my z-score be? Well, to find 0.22 in the table, right, you go to the table, find 22%. And 22% is around a z-score of 0.58 to 0.59. So if you go, 0.58, 0.59, and you look at that, you're going to get your 0.22, your 22% in the table. But it's closer to 0.58 than it is to 0.59. So we're going to use this 0.58. We don't want 0.59, we're using 0.58. So what we do is we say the z-score is that we're going to go up a standard deviation of 0.58, a little more than half of a standard deviation up that way to 0.58, and then back a 0.58, negative 0.58, standard deviation this direction, that realm, that this negative 0.58 to positive 0.58, that interval is your z-score. And with that, landing out.